In the vast expanse of the cosmos, energy is the lifeblood of stars and galaxies. Here on Earth, our civilization's thirst for energy grows with each passing year. We seek clean, reliable power sources to fuel our homes, industries and dreams. Nuclear power, born from the heart of the atom, offers a compelling solution. It's a beacon of hope for a future free from the constraints of fossil fuels and their impact on our planet. Nuclear power plants, unlike their fossil fuel counterparts, do not emit greenhouse gases. They operate silently, without the plumes of smoke that pollute our skies. A single uranium fuel pellet, smaller than a fingertip, contains the same amount of energy as a ton of coal. Imagine the possibilities of harnessing such concentrated power. Nuclear energy has the potential to revolutionize our world, providing abundant, sustainable electricity for generations to come. But with great power comes great responsibility. The promise of nuclear energy is intertwined with the need for utmost safety and security. It's crucial to understand the science behind this powerful force, to dispel myths and misconceptions, and to appreciate the rigorous measures in place to ensure its safe and responsible use. Only then can we fully embrace the potential of nuclear power to transform our world for the better. From the depths of the atom to the vastness of space, the quest for knowledge and innovation drives us forward. Join us now as we embark on a visual journey inside a nuclear reactor, exploring the wonders and complexities of this transformative technology. Imagine a tiny, dense nucleus at the heart of an atom. It's composed of protons and neutrons, held together by a force of unimaginable strength. This is the realm of nuclear energy, where splitting atoms releases energy on a scale far greater than any chemical reaction. This process, known as nuclear fission, is the driving force behind nuclear power plants. The fuel for this atomic dance is uranium, a naturally occurring radioactive element. Uranium atoms are like tiny bundles of energy waiting to be unlocked. When a neutron, a subatomic particle, strikes a uranium nucleus with sufficient force, it causes the nucleus to split apart. This fission releases a tremendous amount of energy along with more neutrons. These newly released neutrons can then go on to strike other uranium nuclei, creating a chain reaction. This self-sustaining chain reaction is the key to harnessing nuclear energy. It's like a controlled atomic dance where the energy release can be captured and used for our benefit. However, this process must be carefully controlled. If the chain reaction were to proceed too rapidly, it could lead to a dangerous release of energy. That's where the intricate design of a nuclear reactor comes into play. At the heart of every nuclear power plant lies the reactor core, a steel behemoth containing the fuel that powers the entire operation. Imagine a giant cylindrical vessel filled with thousands of fuel rods, each containing pellets of enriched uranium. These rods are meticulously arranged in a geometric pattern designed to optimize the fission process. Control rods, made of materials that absorb neutrons, are interspersed among the fuel rods. These rods act as the brakes of the reactor, regulating the rate of the nuclear chain reaction. By inserting or withdrawing these rods, operators can control the speed of the reaction, ensuring it remains at a safe and steady rate. The reactor core is constantly bathed in a coolant, typically water, which serves two crucial functions. First, it absorbs the intense heat generated by nuclear fission. This heat is what will ultimately be used to produce electricity. Second, the coolant helps to moderate the neutrons released during fission, slowing them down to increase the likelihood of them causing further fission events. The reactor vessel is housed within a massive concrete and steel containment structure, designed to withstand even the most extreme events. This structure acts as a final barrier, preventing the release of radioactive material in the unlikely event of an accident. Safety is paramount in every aspect of nuclear reactor design and operation. From heat to electricity, the power conversion process. The heat generated within the reactor core is harnessed to produce electricity through a process similar to that used in conventional power plants. The superheated coolant, now carrying the energy released from nuclear fission, flows from the reactor vessel to a steam generator. Imagine a massive heat exchanger where thousands of tubes carrying the hot coolant pass through a chamber of water. The intense heat from the coolant causes the water to boil, generating steam under high pressure. This steam, now imbued with the energy of split atoms, is directed towards a turbine. The turbine, a giant wheel with blades, spins rapidly as the high-pressure steam rushes past it. This spinning motion is then used to power a generator, a device that converts mechanical energy into electrical energy. The generator produces electricity, which is then sent out through power lines to homes and businesses. The steam, having done its work, is then cooled and condensed back into water in a condenser. This water is then pumped back to the steam generator to be heated again, completing the cycle. Thus, the energy released from the atom's core is transformed into the electricity that powers our modern world. Guardians of safety, protecting people and the planet. Safety is paramount in the design, construction and operation of nuclear power plants. Multiple layers of engineered safety systems are in place to prevent accidents and mitigate their consequences. These systems are based on redundant and diverse principles, ensuring that if one system fails, others are in place to take over. The reactor core itself is designed with inherent safety features. The arrangement of fuel rods and control rods, along with the properties of the coolant, all contribute to a stable and controlled chain reaction. Furthermore, the reactor vessel is designed to withstand extreme pressures and temperatures. In the unlikely event of an accident, emergency cooling systems are on standby to prevent the reactor core from overheating. Containment structures, with their thick concrete walls and steel liners, act as impenetrable barriers, preventing the release of radioactive material into the environment. Stringent regulations and oversight by independent agencies ensure that nuclear power plants operate at the highest safety standards. Operators undergo rigorous training and are constantly monitored to ensure they are following strict safety protocols. The nuclear industry is committed to continuous improvement, learning from past events and implementing the latest safety advancements. Like and subscribe for more.